Hi guys. Okay, this is just a quick video on rational expressions, which is our next topic in A3. Okay, a rational expression is just really a ratio of two polynomials. So the key is you need an x in the denominator. You must have that. So my numerator could be x squared plus 5, like this example, and my denominator x plus 2. That's an example of a rational expression. It's not an equation. There's no like y equals. It's not a function. It's just an expression. And our goal in A3 is just to be able to simplify rational expressions and state some restrictions about them. But I feel like in order to do that, you need to know kind of why we're doing it. So I'm just going to show you why. This part you don't have to really know or ever do until advanced functions. But basically what we're doing is we're examining rational functions and we're getting ready to be able to graph them and see some places where they don't actually exist. So if I had a function that looked like this guy, y equals 3x plus 1 over x minus 2, it kind of looks similar to the functions that we graphed earlier, like in A1, like these guys, those weird ones. Just there's a whole lot more going on. But what I can tell right away from looking at this guy is if my denominator were to equal 0, that's not good. And in order for my denominator to equal 0, x would have to be 2 because 2 minus 2 would be 0. So equaling 0 in a denominator is not good. So that's actually where your restrictions come from, we call them. And the restrictions just mean places on the graph where nothing will exist. It could also be an asymptote. That's kind of like a restriction. So in this graph, where x equals 2, will actually be an asymptote. A place where like x can never equal 2. There's just going to be nothing there. So actually this graph is going to look something like this. So I want to explain about the horizontal asymptotes because you don't need that till grade 12. But your graph is going to look something like this. And again, you don't need to graph this, but I'm just kind of giving you a visual. So by making sure the denominator doesn't equal 0, we can see that's where our vertical asymptote occurs. Okay, but this can also happen. Here's just another example. So maybe a question for you guys would be simplify this expression. And then in grade 12, you would have to graph this expression. So the reason we're doing this year is to be able to get some algebra skills to simplify things. So if I was going to simplify this, the first thing I would do is factor it. So I would factor the top to x minus 3, x plus 3. I would factor the bottom to x plus 4, x minus 3. And then I would see that my numerator and my denominator have a factor in common. X minus 3 can be divided by the top and the bottom. So if I divide the top by x minus 3, that's gone. If I divide the bottom by x minus 3, that's gone. It's kind of like you're just reducing a fraction. If I was going to reduce 5 over 10, I would divide the top by 5 and the bottom by 5, leaving 1 over 2. That's kind of like what we're doing here. We're just dividing the top and bottom by x minus 3. So that leaves the function x plus 3 over x plus 4. So if I was going to graph this function, there's some new information here that you guys haven't learned yet. What happens is this, wherever the denominator is going to equal 0, will give us an asymptote. So in this case, if x was negative 4, we would have 2, 3, 4, we would have a asymptote there because you don't want the denominator to equal 0. That's not good. And if it did equal 0, that would be when x is negative 4. So that's where we have an asymptote. Now, the thing that we canceled out actually has an effect on the graph. It creates a hole there. So we just think about, okay, where would x minus 3, what value of x would make that 0? Well, if x were equal to 3, 3 minus 3 would be 0. So actually what happens when x is 3 is there's a hole in the graph there. So if our graph looks like, something like this. Let's say, which you don't have to know how to graph, but let's say our graph looks like this. Then when x equals 3, there's actually, I should have done a better job of that. There's actually like a hole in the graph there. So there's literally a hole, nothing exists there. So in this course, when you go to state restrictions, you'll say that x can't equal 3 and it can't equal -4. So at -4, there's an asymptote, and at 3, there's a hole. So we always get an asymptote from after we've simplified, whatever's left in our expression, that denominator will give the asymptote, and whatever we cancel, that will give us a hole in the graph. So this is way more detail than you need, but I just wanted to explain it in case you wanted to know. Okay, but your job in this unit is just to focus on the expression. So you're just going to look at this part, and your job is just to use your algebra skills to simplify it. So the best thing to do is to factor it. Always do that first. Factor, factor, factor. So I'm going to look at my expression here. Well, this time it's a function, but we're just going to simplify the expression. So I'm going to factor out a 3n squared for my numerator, which leaves me with an n minus 1. And then in my denominator, it looks like they're all divisible by 4n. So I'm just going to common factor out a 4n, leaving 2n squared minus 3n plus 1. Okay, then I should check, is this guy a complex trinomial? So is there anything that multiplies to 2 and adds to -3? -2 times -1. So just off to the side, I'm just going to do this so I don't take up too much space. I'm just going to try to factor this complex trinomial. Okay, so I found two numbers that do this. So I'm going to replace my middle term with -2n minus n plus 1. Then I'm going to common factor each half. So 2n, n minus 1, minus n minus 1, leaving me with n minus 1, 2n minus 1. So this is just a complex trinomial, and I'm just factoring it. So now I'm going to put that in my equation here, my expression, 4n, and then this will turn into n minus 1 times 2n minus 1. So all I've done is just factored everything. And it's intense. There's a million types of factoring, or 2 in this case. But you never know. Okay, so then I'm just going to see what can I cancel. What's the same on the top and bottom? So I can cancel an n minus 1. Also, this n and the n squared, I can cancel out that n, and then the top will just have a single n. So the final answer will be 3n on top and 4 times 2n minus 1. So that's a simplified expression. And then if I had to write restrictions, so usually it will tell you to write restrictions. All you do to write restrictions is you examine the denominator, even the stuff you canceled out. So you just take each term, and this would be my advice. I would set each term and say that cannot equal 0. And then isolate n. So 4n can't equal 0, that means n can't equal 0 if I divide both sides by 4. If n minus 1 can't equal 0, then let me move the minus 1 to the other side, so that means n can't equal 1. 2n minus 1 can't equal 0, so that means 2n can't equal 1. And then if I divide both sides by 2, that means n can't equal a half. So it's almost like a similar skill to when you're finding the roots of something. You're just taking each bracket or each term and setting it not equal to 0. And that's your restrictions. So we actually have 3 restrictions. It can't equal 0, it can't equal 1, and it can't equal a half. Because that will make the denominator 0. Let's try another one. Simplify and state any restrictions. So this one's just a jumble of stuff. So in these ones, you're really just canceling stuff. So I don't know if this is like really complicated, but I'm just gonna, like 30 divided by -6 would be -5. So just simplify that right off the bat. X to the power of 4 divided by x to the power of 7. This is like an exponent law question. If they have the same base, you can just subtract the exponents, giving me x to the power of 3, or x to the power of -3. But I'm going to put that in the denominator and make it x to the power of 3. And just a quick explanation. It's like you have 4 x's on the top, and it's like you have 7 of them on the bottom. So when you cancel these, cancel, you're left with 3 x's in the denominator. That's how that works. And then y to the power of 3 divided by y to the power of 1. If I subtract those, I end up with y squared in my numerator. So that would be the fully simplified version, kind of just using exponent laws back from grade 9. And if I had to state my restrictions, okay, remember I don't want my denominator to be 0. So really, I just can't let x equal 0, and I can't let y equal 0. Because if this was 0, 0 times anything is 0. If this was 0, 0 times anything is 0. So, okay, next one. Simplify and state restrictions. All right, so let's try to factor. So on the numerator, I'm going to go with common factoring. I think they're all divisible by 2x. So that leaves me with 5x cubed minus 4x plus 2 divided by 2x squared. Okay, I'm not going to check if this is factorable because that's not a skill we need in grade 11. It's like grade 12 skill. You'll be able to factor that in grade 12 if it's factorable. But for this year, all we can do is common. And then we can cancel out these 2's. We can cancel out this x and one of these x's, leaving us with this giant thing on top, 5x cubed minus 4x squared plus 2, and everything's divided by x. And for our restrictions, x just cannot equal 0 because that's what would make the denominator 0, which we don't want. Okay, cool. Sorry, I'm going fast because this video is already long. Simplify and state the domain. Oh, you know what? No, you don't have to do that. Not yet. We'll state the restrictions, which is kind of like stating the domain. Okay, let's factor it. The top is a simple trinomial. So what multiplies to -8 and adds to 7? I'm going with x plus 8 and x minus 1. And the denominator, I think it's factorable by 2. So I'm going to factor out a 2, and it'll be 1 minus x. Oh my gosh. These ones are super annoying. Okay, see how this and this are so similar, but not exactly the same? We got to try to make it the same. Whoops. So if you notice, like in the denominator, the x is negative and the 1 is positive. It's like the opposite in the numerator. Okay, this is kind of tricky. But what you can do, instead of factoring out a 2, what would happen if we factored out a -2? I know that's kind of weird, but you can. So that means I'm dividing each term by -2. So 2 divided by -2 is -1. -2x divided by -2 is positive x. And -1 plus x is the same thing as x minus 1. So this, if you rearranged it, is x minus 1. So that's kind of weird, but we can cancel it now. And that leaves us with x plus 8 over -2. And if I had to state the restrictions, I would say, okay, if you're having trouble with restrictions, just go to the bracket, so -1 plus x, and set it not equal to 0. And then isolate x. So I'm going to bring this to the other side, which will make it a positive 1. So x cannot equal 1. And just check, make sure that makes sense. -1 plus 1, that would be 0. So that checks out. Okay, and the last one. Let's factor it. That's divisible by 4 on top. So I'm going to divide it by 4. Which leaves me with x squared minus 4y squared. And then my denominator is a simple trinomial with an extra y term. So these ones are kind of tricky, but you're just trying to find two numbers that multiply to -6 and add to 1. Oh, sorry. Let's see, what does that? 2 and 3. Let's go with -2, +3. So normally you would just write like x minus 2 and x plus 3, but because they have this extra y, just stick a y at the end, and that'll take care of the y squared and the xy. Okay, but actually I'm noticing this top guy here, that is totally a difference of squares. So we can factor that even more. So I'll just square root each term, leaving me with x and 2y, x and 2y, and then we put a minus and a plus. So that's a difference of squares. Just a tricky one. So you got to be really on top of your factoring game for this unit, because it's just, there's lots. Which is why I've been trying to factor all semester with you guys. Okay, what can we cancel out? This and this, leaving us with 4 bracket x plus 2y divided by x plus 3y. And if we have to state our restrictions, we would say that x cannot equal, oh, actually this one's kind of hard. I maybe cover this in class, but okay, let's set our bracket equal to 0, or not equal to 0, and we isolate x, so x can't equal 2y. And in the other one, let's set this equal to 0. X plus 3y can't equal 0. So x cannot equal -3y. Okay, that's kind of weird, but like, I guess that's how we have to write it. You can't really isolate both variables. So there we go. So that's it. So this whole unit is about simplifying by factoring and canceling. So if you go to week 7 homework, you guys should be able to do question 1, question 2, because these are all polynomials. Question 3, question 4, and question 5 and 6. So you can do all the way to question 6, and then we will cover 7 and 8 tomorrow. Okay, awesome. Hope that wasn't too complicated.